Chapter 4, Section 2, Changing Forms of Energy. More likely to think of energy as race cars, you are more likely to think of energy as race cars, or past, or as your body uses energy from food to help it move, or as the sun warms your skin on a summer day. These situations involve energy changing from one form to another. Light bulbs transform electrical energy into light so you can see. The warmth you feel around the bulb is evidence that some of that electrical energy is transformed into thermal energy. Fuel stores energy in the form of chemical potential energy. The engine transforms the chemical potential energy stored in gasoline molecules into the kinetic energy of a moving car or bus. Several energy conversions occur in this process. In a car, spark plug fires, initiating the conversion of chemical potential energy into thermal energy. As the hot gases expand, thermal energy is converted into kinetic energy. Some energy transformations are less obvious because they do not result in visible motion, sound, heat, or light. Every green plant you see converts light energy from the sun into energy stored in chemical bonds in the plant. You have experienced many situations that involve conversions between potential and kinetic energy. To understand the energy conversions that occur, it's helpful to identify the mechanical energy of a system. Mechanical energy is the total amount of potential and kinetic energy in a system and can be expressed by this equation. Mechanical energy equals potential energy plus kinetic energy. An apple on a tree has gravitational potential energy due to Earth pulling down on it. The instant the apple comes loose from the tree, it accelerates due to gravity. As it falls, it loses height, so its gravitational potential energy decreases. This potential energy is transformed into kinetic energy as the velocity of the apple increases. If the potential energy is being converted into kinetic energy, then the mechanical energy of the apple doesn't change as it falls. The potential energy that the apple loses is gained back as kinetic energy. The form of energy changes, but the total amount of energy remains the same. Energy transformations in projectile motion. Energy transformations occur during projectile motion when an object moves in a curved path. This graphic will show you occurrences of high kinetic energy and low gravitational potential energy, low kinetic energy at the top of the arc where the ball comes to a pause, high gravitational potential energy, and as it falls you get high kinetic energy and low gravitational potential energy. So once again, from the bat, high kinetic energy, low gravitational potential energy because it's close to the ground. As it reaches the top of the arc, you have low kinetic energy as it reaches the top, and high gravitational potential energy because of the distance to the ground. As it falls back to Earth, the kinetic energy increases and the gravitational potential energy decreases as it gets closer to the ground. Energy transformations in projectile motion. The mechanical energy of the ball remains constant as it rises and falls. It's just going back and forth from kinetic to potential energy. When you ride on a swing, part of the fun is the feeling of almost falling as you drop from the highest point to the lowest point of the swing's path. The ride starts with a push that gets you moving, giving you kinetic energy. As the swing rises, you lose speed but gain height. In energy terms, kinetic energy changes to gravitational potential energy. At the top of your path, potential energy is at its greatest. And then as the swing accelerates downward, potential energy changes to kinetic energy. Energy can change from one form to another, but the total amount of energy never changes. Even when energy changes from form from electrical to thermal and other energy forms, as in a hairdryer shown, energy is never destroyed. The law of conservation of energy. This principle is recognized as a law of nature. Law of conservation of energy states that energy cannot be created or destroyed. We can just change its form. You might have heard about energy conservation or been asked to conserve energy. These ideas are related to reducing the demand for electricity and gasoline, which lowers the consumption of energy resources such as coal and fuel oil. The law of conservation of energy, on the other hand, is a universal principle that describes what happens to energy as it is transferred from one object to another or as it's transformed. While coasting along a flat road on a bicycle, you know that you will eventually stop if you don't pedal. If energy is conserved, why wouldn't your kinetic energy stay constant so that you would coast forever? You know from experience that if you don't continue to pump a swing or be pushed by somebody else, your arcs will become lower and eventually you'll stop swinging. In other words, the mechanical, the kinetic, and the potential energy of the swing seems to decrease as if the energy were being destroyed. Is this a violation of the law of conservation of energy? With every movement, the swing's ropes or chains rub on their hooks and air pushes on the rider. Friction and air resistance cause some of the mechanical energy of the swing to change to thermal energy. With every pass of the swing, the temperature of the hooks and the air increases a little, so the mechanical energy of the swing is not destroyed. Rather, it's transformed into thermal energy. And it goes back to the experiment we did with the paperclip. When you bent the paperclip, the kinetic energy of you breaking the paperclip was transformed into thermal energy. Converting mass into energy. The special kind of energy conversion, nuclear fusion, takes place in the sun and other stars. During this process, a small amount of mass is transformed into a tremendous amount of energy. In the reaction shown here, the nuclei of hydrogen isotopes deuterium and tritium undergo fusion. It means they are fused together. In processes involving nuclear fission and fusion, the total amount of energy is still conserved if the energy content of the masses involved are included. Then the total energy before the reaction is equal to the total energy after the reaction, as required by the law of conservation of energy. What forms of energy can you find in the human body? With your right hand, reach up and feel your left shoulder. With that simple action, stored potential energy within your body was converted to the kinetic energy of your moving arm. Some of the chemical potential energy stored in your body is used to maintain a nearly constant internal temperature. A portion of this energy also is converted to the excess heat that your body gives off to its surroundings. Your body stores energy in the form of fat and other chemical compounds. This chemical potential energy is used to fuel the processes that keep you alive, such as making your heart beat and digesting the food you eat. Your body also converts this energy to heat that is transferred to your surroundings, and you use this energy to make your body move. The food calorie, represented by the letter C, is a unit used by nutritionists to measure how much energy you get from various foods. 1 C is equivalent to about 4,180. 1 C is equivalent to about 4,184 joules. Every gram of fat a person consumes can supply 9 calories of energy. Carbohydrates and proteins each supply about 4 calories of energy per gram. Total amount of kinetic energy and gravitational potential energy in a system is the mechanical energy of the system. Mechanical energy equals KE plus GPE. Law of conservation of energy states that energy can never be created or destroyed. The total amount of energy in the universe is constant. This concludes the lecture notes for section 2 of chapter 4. We'll go through these questions. Question number 1. Mechanical energy is the total amount of kinetic energy, momentum, potential energy, or potential and kinetic. ME equals PE plus KE. Therefore, the answer is D. Mechanical energy is the energy due to position and motion of all objects in a system. Question 2. State the law of conservation of energy. Just like all the other laws, the law of conservation of energy states that energy cannot be created or destroyed. Question 3. Friction converts blank energy into blank energy. Friction converts electrical energy into thermal energy. Oops. Friction converts, excuse me, I didn't see that answer, mechanical energy into thermal energy. Mechanical energy, the KE plus the PE, is transformed because of friction into heat, which is thermal energy. Letter B. This concludes the lecture notes for chapter 4. Your homework assignment will be to complete the online section 2 review.